Welcome everybody to my presentation, Tips and Tricks on Platform Code Implementation in .NET MAUI. So my name is Luis Beltran. I am a Mexican Microsoft MVP in AI, Developer Technologies, and Azure. I am currently studying in Czech Republic. I am pursuing my PhD, and most probably I will finish this year, so looking forward to it. I am also a lecturer at Tomás Bate University in SLIM and at Tecnológico Nacional de Mexico in Celaya. I send special greetings to people who are attending this session in Mexico. So hello friends, thank you very much for being here. So let's get started with our topic. When we build a cross-platform application, it is quite typical that you would like to reuse as much code as possible. However, there might be some scenarios where it makes sense that your code needs to be platform specific. For example, you want to access some Bluetooth device. In .NET MAUI API, there is no direct, let's say, a class to do that. So you need to write code in Android or in iOS class. Or maybe you want to customize the visual component or the visual appearance, like a camera view. So you need to write code in the platform specific. You know that in Xamarin Forms, we use two techniques, dependency service and custom renderers. In .NET MAUI, we have dependency injection and also handlers. In the end, these strategies or these capabilities of .NET MAUI allow us to take advantage of multi-targeting, partial classes, dependency injection in order to access platform-specific functionality, behavior, appearance, and so on. And of course, if you go to the documentation, you will find how to do it. But please, let me share some tips that might be useful for you. So the first tip is, if you are going to implement native functionality, use dependency injection, which is a built-in capability in .NET MAUI. So just as a brief summary, dependency injection is a technique in which an object or a client receives other objects that they depend on. For example, services. There is an element known as injector, which is a method or some code that passes a service object to the client object. Actually, dependency injection is a specialized version of some pattern known as inversion of control, where the concern being inverted is the process of obtaining the required dependency. Actually, with dependency injection, a service class is responsible for injecting the dependencies into an object at runtime. And there are several advantages of implementing or using this capability. For example, coupling reduction between classes and dependencies. We create a reusable code, testable and maintainable. But before dependencies can be injected into an object, we need to register those types of dependencies. And we do that by passing to the container an interface and the concrete type that implements the interface, that is a class. So how to take advantage of this dependency injection? I have some steps. So the first one is, don't forget that in .NET MAUI you only have one project. But if you want to implement platform specific, there is a platforms folder. Okay, so the first step, create an interface that is part of the project. I will define this one as shared interface. Here you will define your contract, methods, properties, and so on. So in this case, I have an interface iPhotoPicker. Good. And I define method getImageStreamAsync. Second step, create classes. And these classes are the platform-specific ones. So for example, I will create class for Android and class for iOS. And they are placed inside each subfolder in the platform's main folder. So you can observe that on the picture. And you can also see that they share the same name. We have PhotoPicker in Android folder and PhotoPicker in iOS folder. Moreover, they share the same namespace, so platforms, for example, and they implement the previous interface. So here you will find the actual code for the method that we defined earlier. Okay? And in this case, for example, you can see intent code, main activity. So this is for Android, and this is for iOS. So the objective is, for example, to get some solution that can allow the user to choose a photo from their device. So yeah, we have now two steps. The third one is very easy. Register your dependency. You do that in MAUI program file or class, and there you register by using builder services at singleton. Yeah, and you pass the two types, which are the interface and the class. Since we are using the same class name, that is PhotoPicker, and the same namespace, it is very simple. Everything is reduced to just add this using, for example, netconf demo.platforms, and that will be all. And of course, then you can use it. But please notice the following. In the previous step, we are registering the dependency in the dependency container. So that means that the interface is available to be injected, for example, in the constructor of some content page. You can observe here, we have iPhotoPicker, local reference, then this is the one that is injected or that we can obtain. And of course, maybe when we press some button, we can call this method, getImageStreamAsync. When the application is running, it will execute the platform-specific code that is part of the compiled package. Let's see a demo. Okay, so in this case, I'm going to run this application, and everything that I mentioned is already there in the structure or in the solution. But okay, so in this case, we have this first content page. So we can click on the button, and since it is Android, it will allow us to select some picture, let's say, from our picture folder. Yes, so this works. And yeah, in this case, you can observe what I mentioned earlier here. So we have the same namespace and also for iOS. However, I will not show iOS, but it works. So you can tell me. You can. I will share the repository a bit later, the link. But yes, everything is easy. So it is as easy as 1, 2, 3, 3 simple steps to get your platform-specific codes implemented in a .NET MAUI project. Of course, this means that you need to know a bit of, I don't know, Xcode or Android SDK in order to implement the functionality. It might be easy, it might be complicated, it depends on the of course, on the particular APIs that you would like to access. But the .NET MAUI API just, let's say, delegates that task to the platform code, and all you need to connect everything together is the interface and then the classes, right, that you define with the same name and also in the same namespace. And don't forget that we are using, or .NET MAUI uses multi-targeting. So that means that this is not an error, there is no mistake, even though we have defined the same class several times, I mean in different files or in different folders, but they are using the same namespace. But it doesn't matter because of the multi-targeting. Okay, so if you have any questions, please let me know. At the end, I will try to do my best and answer them. So this is regarding platform-specific code. What happens if you want to, for example, implement a new control or modify the appearance of one of the views? Well, for that you will use handlers, and you can do it by using partial classes or also compiler directives. So I will recommend partial classes. Just as a summary or introduction, handlers are used to customize the appearance and also the behavior of a cross-platform control by using the native API of the control. And this customization is achieved by modifying a mapper for the handler. Every handler class exposes a native view for the cross-platform control through an element known as platform view. And you can use it to set properties, invoke methods, subscribe to events of the native view. Furthermore, the cross-platform control implemented by the handler is exposed by a virtual view property, and you will see in the code in a minute. Handlers can be customized per platform by using, as I said, conditional compilation to multi-target code based on the platform. However, my personal recommendation is to use partial classes because it allows a better organization of your code and also simplifies the implementation in the platform-specific folders and files. So, how can we do that? There are 5 steps. The first one, again, define an interface, and this interface is a shared one. So it goes, let's say, on the main project or the main element, the main folders. So this will be known as shared control definition. This interface implements the iView interface in case that you want to create a new control. For example, in this case, I would like to define some surface where the user can draw by using the finger or some pointer. So the idea is, for example, you can create some control that allows the user to sign, let's say, and then we can save that signature into a file. So in this case, we define one property, which is a color, draw color, and 2 methods. One to clear the area, and all second methods to save the picture. But remember that this is just an interface, so we just define the contract, okay? In case that you would like to actually extend the customization, extend the behavior or the appearance of some control, you will, instead of iView, you will implement the specific interface like iButton, iEntry, or others, okay? But also, as part of this first step, you will create a new class. And this class implements the previous interface. It extends either view or the specific control like switch, button, entry that you would like to extend. View is if you want to create a new one. Maybe you can also set bindable properties for the appearance, and you can also create methods for customizing the behavior. And well, in my case, I noticed that it is easy to define, let's say, or subscribe to some methods by using messaging center. However, yesterday or 2 days ago, sorry, we noticed that this characteristic is now deprecated in .NET 7. So you can use weak reference messenger or a strong reference messenger in the community toolkit MVVM, right? So yes, later I can update this project with the recommended approach. But for this case, let's stick with Messaging Center. And as you can see, we send clear and safe messages, all right? Well, we move to step number 2, and here is where things can become a bit complicated, but let's bear with it. So we are going to create a second interface. This one implements iViewHandler, and here we can set the platform view to a platform-specific control that maybe exists if we are extending it, or since it is a new one, we will implement it later. To set that platform view, most probably we will need to use conditional compilation, but please, you can see that it is only at namespace level, because you can use also conditional compilation in your code, in your class. But I believe that the class can be overwhelming, and also the code cannot be manageable at all. So yes, at least we will use conditional compilation, but only in the namespace part. You can observe that depending on the platform, we will set the platform view to a specific control. For example, one for iOS, one for Android. These are controls that I create myself, or they are implemented in the platform. It is fine, but it could be something like UI button, for example, or some widget button, I don't know, from a specific, that they already exist. And also on the same step number 2, now we create a class that implements the previous interface. Here we can start setting some of the members that I defined earlier in the when I explain handlers. So here you can set the property mapper. The property mapper is basically some kind of dictionary with which sets an entry for a property and the actual property that is defined in the interface. So for example, draw color. Also, we can set the virtual view and the platform view. In this case, the virtual view is part of the handler, and the platform view is a specific view or control from Android, iOS, Windows, and different platforms. Then we can set a constructor that passes this mapper, property mapper, and we can also set other methods like connect handler, disconnect handler, and also specific methods. So in this example, you can see that we set the platform view, we have the constructor, and also we implement draw color method, and we also override connect handler and disconnect handler. In this case, we use connect handler to actually subscribe to messaging center, and in disconnect handler we unsubscribe by sending the clear and safe messages. And there is also on message clear and on message safe, which basically call clear method and safe method. These two methods will be defined later in the platform specific code. Actually, that is step number 3. Implement the native handler. In this case, you will create a partial class that will be placed in every subfolder into the platform's main folder. So for example, we will have one for Android, one for iOS, and so on, with the same namespace as the handler. So for example, you can observe handlers that I define in the interface. And here we extend view handler class, and we define two types, the iView interface and also the native control. In this case, it is a custom one, the one I created, that will control Android, the code you will see in a minute. And here you can implement some methods. If you didn't do it before, here you can implement create platform view, connect handler, and disconnect handler. If you remember, we already implemented them, so no need to do it here. And well, in this case, I am creating a class, draft view control Android, which extends from view. And you can see that actually, for example, I have some properties like paint color, but most importantly, I have clear method and save method. These two methods will be called when I, for example, execute this line platform view.clear. It will run this line if we are, of course, executing the application in Android. And then the same happens for iOS. We have the draw control handler for iOS and also the native control if you need to create a new one. The fourth step is very easy. All we need to do is to register our handler. So configure MAUI handlers, and here we add it. We add two elements, the control and the handler, and then we can use it. So we can do it, for example, in SAML or C#, and then we can call these two methods, clear and save. So let's demonstrate it. So I will run again my code, and we can move to the second example. So let's go to draw, and here it works, right? So yes, I have some area where I can draw. I can clear it, or I can do again, save. And if we go to the pictures folder, we will see the new element. Yes, so this one. Okay, so it works. And to conclude, because we are short of time, the third tip is actually to use the same technique, similar partial classes and partial methods to implement native functionality. If you remember, at the beginning, we implemented native functionality with an interface, but we can do it also with partial classes, and actually it is also easy. So all we need to do is to create a partial class definition, but also partial methods. But please observe that this partial method is kind of similar to an interface because we don't define the specific, here we just set the definition, that's it. And later, actually, in every platform folder, like Android, iOS, we create again the partial class and the partial method, but now we write actually the code. So actually this code is the same one that I used earlier. But most important, you need to use the same namespace, and also the same method name. You do it also for Android, for iOS, sorry, and then you use it. In this case, you are not registering anything, so no problem. But you need to create an instance of the, for example, photo service, and then you call the method. And the demo is, let's say, exactly the same one as before, but I have, let's say, a new page where I do exactly the same. We can select a new member, and it is displayed there. Okay. So, well, these were these 3 tips that I hope that they are useful for you. So there are 2, let's say, for platform specific, 1 for custom handlers, and well, you can download the code in this repository. So please, if you have any questions, I will do my best to try to answer them. Thank you very much for your time.
Thank you. That was really good. I mean, I think for any cross-platform UI framework, handling the native aspects is always a challenge, and I think the DI system works really well for that. That's a very elegant solution, very powerful.